All right, one more problem from section 6.4, which is the section on work. We have the following problem here. It says that when gas expands in a cylinder with a radius r, the pressure P at any given time is the function P equals P of E. So we get a pressure function with respect to the volume V. The force exerted by the gas on the piston is the product of the pressure and the area. So the force is equal to pi r squared times P. The work done by the gas when the volume expands from a volume 1 to a volume 2 is given by work equals the integral from V1 to V2 of that pressure function P of V dV. All right, so for our particular problem, in a steam engine, the pressure and volume of a steam satisfies the equation P times V raised to the power 1.4 is equal to K, where K is a constant. We want to calculate the work done by the engine during a cycle when the steam starts at a pressure of 140 pounds per square inches and a volume to a volume of 300 inches and expands to a volume of 800 inches. We're going to round our answer to 2 decimal places. So I see a lot of inches being used here. We know that the unit for work that we're going to use is foot-pounds. So I'm going to start this problem by just making a few simple conversions to the values that are being given. All right, so I'm going to start here with P. A different color here. All right, so P is equal to 140, and so this is pounds per square inches. So in order to convert, I want to get rid of inches and turn that into feet. So really what I want to do is multiply. We know that 12 inches is the same thing as 1 foot, but I'm going to have to square these values to kind of get the inches square that I have in the denominator here. So this gives me a value of 140 times, so I will have, currently we have pounds per square inch, so I will multiply by 144 square inches over 1 square foot, and this gives me a value of 20,160, and now this will be measured in pounds per square foot. All right. I also want to convert the units for the 2 volumes. So the first volume that we're dealing with is 300 cubic inches. And again, my conversion factor here, 1 foot is equal to 12 inches. But we need to cubed in this case. We need to work with a unit cubed. So 300 inches cubed times 1 foot over, I'm just going to write this as 12 cubed inches cubed. So we need to divide 300 by 12 cubed, and that gives me 25 over 144. And again, just in case this is not clear, you'll see that the inches and the inches are going to cancel out very nicely here. And so this will be measured in cubic foot. All right. The same thing for that second volume. I have 800 inches cubed. And again, in the same way, I want to convert inches cubed to foot cubed. So I'll multiply by, 1 foot over 12 inches. We're cubing this value, of course. So I have 800 inches cubed times 1 over 12 cubed. And so this will be foot cubed over inches cubed. And this gives me a value of 25 over 54 cubic foot. All right. So we're now ready to start the problem. I'm actually just going to flip over here. So these are the values that I'm going to use. They've already been converted to the correct units. So for step 1 of my problem, let's go ahead and see if we can find that constant K. Now, remember that K is equal to that initial pressure times the initial volume raised to the power 1.4. And I'm just putting the footnotes initial on there so that you can see that we're using the initial values. So this will be equal to, let's see, that's going to be my 20,160. All right, that's the initial pressure. And then that initial volume was 25 divided by 144. And that number will be raised to the power 1.4. So when I evaluate here, I get 1,737.397. I do get a longer decimal, which I will round. I'm going to keep that original value stored in my calculator for further calculations. All right, so step 1 done. We found K. Step 2 would be to, let's just give, now that we have K, can you give the pressure as a function of V, right? So pressure as a function of V. So remember, since we were given, and we just used it, K is equal to P times V raised to the power 1.4, we can just solve here for P. So if we solve for P, we see that P is equal to K divided by V to the power 1.4. Or if you would like to, we could write this as P equals our K value, and we could write this as P of V. So it's going to be equal to the K value. I tell you what, let's write it like this first. Let's just make this really clear. This is K times V to the negative 1.4. So let's say that pressure as a function of volume is equal to 1,737.397 times V to the negative 1.4. So now that we have the pressure function, we can find work. And remember that work is just equal to the integral from V1 to V2 of that pressure function that we just found, dV, with respect to V. So for us, this is going to be the integral going from, let's see, 25 over 144 all the way to 25 over 54 of this function 1,737.397 times V raised to the power negative 1.4 dV. All right, so let's go ahead and integrate. When I integrate, this is equal to, so constants hold over. So this will be 1,737.397. And we're integrating V raised to the power negative 1.4. So add 1 over add 1. Add 1 to that exponent makes it negative 0.4. But we have to divide by our new exponent. And then I'm going to be evaluating from 25 over 144 all the way up to 25 over 54. All right, so we will need to plug in top minus plug in bottom. So I get 1,737.397 37.397 divided by negative 0.4. Plug in top minus plug in bottom. So I get 25 over 54 raised to the power negative 0.4 minus plug in bottom. 25 over 144 raised to the power negative 0.4. All right. So at this point, I would definitely say use your calculator to evaluate that. And let's see, when I evaluate it, I got 2,839.5498. And this will be measured in foot-pounds.